Hello. All right, I'd like to say a couple of things about experiments and causal inference. Experiments are generally the um, golden standard of establishing causal inference and therefore internal validity of a study. So, how can we best do that? Well, one of the main things here is to remember that what is it that's required to establish causal inference, and that's how we'll see that the experiment uh, is a method that captures very nicely uh, those requirements. So we know that covariance is not the same thing as causality. So we need more than correlation. But just because we need more than correlation does not mean that we don't need that. Correlation is a necessary but insufficient condition of causality. So here we can observe, for instance, that the amount of binge drinking may decrease after people are sent into a program stressing the dangers of alcoholism. But could there be other reasons for that decline? If there was no decline in binge drinking for the program, then we could assume that there is no causal relationship because there will be no correlation. You have the program and you don't see a transition in terms of the dependent variable that you're looking for, then you can be pretty confident that there is not a causal relationship. But this does not rule out alternative explanations for the change if the correlation is present. So think about that. Hopefully that makes sense. This is why we want to make sure that we have non-spurious relationships. We've talked about spuriousness before, but the purpose of the experiment is to actually eliminate the potential spuriousness that could exist. So the experiment, by having an experimental group usually and a control group, can control for some of these alternative explanations. There are other ways that we can do this in secondary data analysis, usually using something called multivariate regression. But the key thing here is that experiments are very good ways to control for or hold constant other potential explanations. So once we do that, and if after holding those other explanations constant, we still see the variation in the dependent variable due to manipulation or changes in the independent variable, then we can more safely attribute the remaining variation in the dependent variable to changes that were made in the independent variable. So we can establish the link between those two things. Now, when you use statistical techniques, for instance, with secondary data analysis, using quantitative methods such as multivariate regression, you're always at risk of omitting some important variable that could perhaps explain the variation better or be the real explanation for the variation. So that risk exists in many forms of study. Experiments are pretty good at reducing the omitted variable bias by generally controlling for those common elements between different social groups. So time order. Time order is another important phenomenon. We know that you need to have time order to establish causality, and that means that the cause has to come before the effect. If you do cross-sectional research, and a lot of quantitative research is cross-sectional, then you can't really establish the time order. And so to know which comes first, it's important. So for instance, this also helps to establish the causal direction. Some relationships, it's obvious which way the causal direction goes. we know that infant mortality, a decrease in infant mortality would not lead to an increase in public health spending. You can think about that in the sense that, okay, if the situation is getting better, why would you spend more money on it if it's being solved? So there we could establish that it would be the increase in spending that would lead to the decrease in infant mortality if that is the case. However, what about the relationship between educational attainment and gross national income per capita? So is it that as the population has higher education, that then leads to a more productive economy? Or is it that a more productive economy provides the resources for the state to provide higher education and better educational quality? So those questions of time order are important, and they can be addressed through longitudinal research, but they're also addressed in an experiment because the experiment manipulates the independent variable, and then you measure the dependent variable and so forth. We'll see that oftentimes you take a pretest, which gives you a measure of the dependent variable's value before the intervention of the independent variable. Then you introduce the independent variable, and then you measure again. And that allows you to see what type of change is due to the introduction of the independent variable. At the same time, of course, you have a control group that helps to control for spuriousness. So that's why it's called a control group. What you're actually controlling for is other alternative explanations. So that gets us into some of the important elements of experiments. One of those elements is, of course, comparison. We're comparing these measurements before and after in terms of the treatment variable or the independent variable in a random sample in a single group. That's a within group design. Now notice that the sample is random, and this allows us some external validity and also allows us to to control for other variables that could, or competing explanations. So if you did not have a random sample, then we would not know if, say, the change was due to some unique quality of those people who were non-randomly selected, or if it was due to the introduction of the independent variable. The other way to do the comparison is the between group design, which is the more common form, and that is comparing the dependent variable in a control group to one in an experimental group. So, and actually, you oftentimes get both of these in a classic experiment. You have the measure the dependent variable with a pretest, and that gives you the before and after, and you have the comparison between the experimental and the control group. So manipulation simply refers to the introduction of the treatment variable in an experiment. That's a simple vocabulary term. But most experimental designs, and you'll see a variety of them in this PowerPoint, not in my actual presentation, but if you go and scroll through, you'll see the different designs, such as the Solomon four-group design and so forth. And these models that include a pretest measure, followed by this introduction, they assort the time order, and that's important to keep in mind. Now, this is all to help establish what we call internal validity. Again, that internal validity of a research design here is what we're focused on, the second of these two definitions. And that is the degree to which a study establishes a causal effect of the independent variable on the dependent variable. That is the central question of research methods. It's the central point of doing research. How do you know? Does it answer that epistemological question? And experiments are a method that can do so. Now, oftentimes people may think that they're not very convenient for the social sciences, but there are a number of experiments, and the particular method of experimentation does seem to be growing in the social sciences. Please watch a couple of the videos that I've posted here that show some example of how experiments have been used in the social sciences and that have led to some pretty important implications for our discipline and also for what's wrong with our society and needs to be addressed. So when we talk about threats to validity, there are both extrinsic threats and intrinsic threats. Extrinsic threats are those that are outside of the study design itself. Intrinsic threats are developed from problems within the study design. So let's talk a little bit about some of these extrinsic threats to internal validity. One of those is selection effects, and that is when the study's participants are different from the population to which we want to compare them, and that introduces a bias into the study. So, for example, if I want to examine the impact of a tutoring program by comparing the average improvement in grades of people who obtain tutoring than those who don't, what we have is perhaps a self-selection bias. Those people who decide to obtain tutoring may be more motivated, may be better students in general, and thus can we say that the improvements observed are really due to the tutoring program or to the fact that these people were more likely to actually spend the time, study, and learn, and were more motivated to begin with? So that's an issue with selection effects, and sometimes that can be injected into the design of a study. Now, how do we prevent that? Well, we can do that through matching, and that is a way that we attempt to ensure that these groups are similar, the experimental and control groups, and the demographic and other measures. And we have two ways of doing this, which you'll be able to read through: precision matching and the other average form of matching, the frequency distribution matching. The key difference between these two forms of matching is that the precision matching tries to match each individual in the experimental group with an individual in the control group so that they are basically identical in terms of the demographic variables that have been selected. Problem is that you can have a very large sample, and that can be difficult to find a right number of 23-year-old African-American females and the right number of 26-year-old Latino males, for example. And the more variables that you want to control for in this, say we had an income variable, 26-year-old middle income Latino female versus a say a 35-year-old female wealthy Filipino non-English speaking individual. So if the more variables you want to control for, the more difficult it is to have that precision matching done. So as an alternative to that, there's the frequency distribution matching, which just tries to capture each individual and all the characteristics, but allows each characteristic to be separately matched. And finally, the final alternative to that is random selection, and you can use various forms to do the random selection, such as an appendix in the back of your book, which is a random table. There'll be a random table there that you can use for random selection, and there's many computer programs that also can do that. And but the key here is that each individual from the target population has an equal opportunity to be selected. And when you put that into practice and you couple that with the epistemological power of the experiment, you have a pretty good epistemologically based methodology, provided you've also addressed the internal threats to validity discussed in the next video. Thank you.